last time we went through some introduction, okay, including my introduction and the introduction of the course. So first of all, we looked at why do we do the design. So design is done for solving a problem, okay, and problem can be that you have something which you want to correct, repair, okay. My car is broken, my phone is not working, these are all problems, right? Okay. Another problem could be something which I want to achieve, something which I want to have, okay. For example, having a projector, okay. If this projector is not there, I don't have a problem, but to teach I need the projector, right? So problems can be something which is not working properly, or problem can be something which you need, okay. And to solve both these types of problems, you need to do the design, okay. So design is for solving a problem. For example, in your home you need a kitchen, okay. So without the kitchen you will not die, okay, inshallah, obviously. But you need the kitchen right, to cook, okay. So then we need the design. We need to communicate our design, and this is where we need the drawing, okay. The drawing is used for telling our design to other parties in the project, okay. And so the the drawing can be used for communicating your design. It can be used for generalizing your design. Generalizing, I told you, you did something at one place and now you tell me do the same at the other place as well, okay. So you show me one chair, drawing of one chair, and you say 100 chairs like this. This is called generalization, okay. And drawing is also important for documentation, okay. So if you go somewhere and start doing a project at that place, the first thing you will ask for is the old drawing of that area, okay. This is how it usually happens. So you buy land, now you want to construct your own villa there. You cannot do any construction, you cannot do any design until you have the old drawing of this area, okay, on the basis of which you will do the design for future, okay. So when you are doing the design for villa, you need the electricity, right? You need the water pipeline. So how would you know where is the pipeline? How would you know where is the electricity line going? How would you know? You have to check it from the old drawings, okay. So drawings become part of important documents related to the project, important documents or important record of the project, okay. The drawings can be of two types. It can be sketch or it can be a technical drawing. What you draw for your design, it could be a sketch, it could be a technical drawing, okay. Now which one is more accurate, a sketch or a technical drawing? Technical drawing is more accurate, okay. Sketch just gives you the idea without any details, okay. So so you can see the examples of the sketches here, okay. So in the sketch you should just keep in mind that the things are in the correct shape and they are in the right proportion, okay. So if I make the sketch of this table, okay, you can see the screen is big, the laptop is small, right? Okay, so it's not accurate. If I make a sketch, it will not be accurate. It will not show the exact dimension of the laptop, but the laptop should be smaller than the screen, okay. So a sketch is just to see the correct shape and form of your design, okay. But you cannot use it for measurement, you cannot use it for construction, okay. For that you need the technical drawing. So technical drawing becomes a reference for construction, becomes a reference for working on it, becomes a reference for manufacturing it, okay. So if you want to manufacture a car, you can draw a sketch of the car, right? Even my daughter can make a car on paper. She is like 7 years old, okay. but I cannot take her sketch and give it to a car manufacturer and tell him, okay, make this. He will need more details, right? So the details are from technical drawing, and they are accurate, they have all the dimensions, they have all the details. So now you can use it for construction and manufacturing. Okay, so if you are the contractor, you cannot construct a sketch. You can construct according to technical drawing. Got it? Clear? Okay. So technical drawing can be for anything. It can be for something which is as simple as a spoon or as complicated as a spaceship. Okay. Now, and then I moved on to why technical drawings are important for us as civil engineers. Okay. So without the technical drawings, you will face a lot of problems in your project because you don't know what to do. Okay, if you don't have the technical drawing and you start constructing it, you will not know what to follow. Okay, so your project cannot be successful if your drawings are not complete. Okay, this is what it means here. Okay, and I told you why we call it the blueprint. Anybody remembers why we call this as a blueprint, the drawing? The final print? Yeah. Yeah, the final paper, when they used to do it everything manually, they used to print it in blue color. So that's why we call it the blueprint. Okay. So the term is common now. Okay. So it's not only used in civil engineering, it's used everywhere now. Okay. Blueprint means something which you will follow. Something which you will follow. And the terms comes from civil engineering that the final drawing used to be in blue color. Okay, so this is what you have to follow. The engineer may have other drawings with him, but they used to be in other colors. So if you have like a file of drawings, okay, the engineer tells you, okay, this whole file, take it, put it in the record. Okay, some of them are in blue color, some of them are in white color. If somebody takes them after 2 years, they want to see which one was used for construction, the one which was in the blue color. Okay, so that's why they call it the blueprint. Anyways, coming back to the point. If your drawings are not accurate, if they are not complete, then most definitely your project or your construction will not be according to the requirements of the client. Because how do you know the requirements of the client? From the drawing. Okay? Or your construction will not be according to the design. Because how do you know about the design? From the drawings. Okay? So for your construction work to be successful, your drawings must be complete and accurate. Clear? Okay? Everybody? Okay. And that's why we call it the blueprint of success. Okay? So technical drawings are very accurate. They are very precise. Okay? And anybody can understand them. You are looking at a picture, right? So you don't need to worry about is it in English or in Arabic or Urdu. Okay? Or I don't know about civil engineering, I don't know about mechanical engineering. You can see and you can have an idea. Okay, so it becomes easier to communicate. And as I mentioned, if your drawing is complete and accurate, there are less chances of error, less chances of mistake, because you have to follow this, right? Okay, so if I tell all of you, make this line. Okay, can you make it? Can you make this line? Make it. Okay, make it. Make this line. Done? Done. she is the one who saw the message at the end, right? I just added you in the class. You are the one who's supposed to see it before. Anyways. Yes. What is this? We'll make the line, right? You make the line. Did you make the line? Yes. Okay. Is it the same line? Yes. Huh? Same line? Yes. You brought the scale as well? Okay, my line is 8 centimeter. Whose line is 8 centimeter?
1 centimeter.
8 centimeter. My line is 8 centimeter. Yours is not, right? Definitely. Is it 8 centimeter? This is not 8 centimeter, right? Okay. Is it 8 centimeter? No, is this line 8 centimeter? No. Right? Okay. Now tell me, this line is a sketch or a technical drawing? This line is a sketch or a technical drawing? It's a sketch, right? Now you try to follow it. It's not accurate. It's not accurate, right? Without details, like this. Sketch is a rough sketch. There is no dimension, there is nothing. Get my point? My point was, coming back to the point, why we need technical drawing? Now you see, even if you want to construct one line without any specification, you will make a mistake, right? You use the pen to do it, right?
Yes.
You draw it with a pen. Okay, can you delete it?
No,
You cannot. Okay, now in order to remove this line, you have to tear the paper, right?
Yes.
Huh? You have to tear the paper. What if this was a wall and you made it, and later on you found, oh, this wall is supposed to be 10 meters. Now how would you correct it? So you made the wall 12 meters. It was supposed to be 10 meters. It's not a line. Even if it's not a line with pencil, you can delete. If it's not a line on the paper, you can just remove. Now it's an object on the ground, and you did the construction without using the correct dimension. Now what would you do? Break it. Okay, and when you break the wall, the labor and the material which you put in for constructing that wall is, most of it is wasted. Okay? We need more money, right? We need more money, we need more time. Okay? And the client is not happy. He will come and what did you do? Okay? So, even if something is as simple as a straight line, by the way, it's not straight as well. I know my hand doesn't go straight. Okay, I know. Okay, when I was in high school, I used to write like, my writing goes like this. It doesn't go like this.
Yeah.
Okay. What here? Have you seen me writing? Don't say yeah to everything. Anyways, so it used to go like this. Okay, and I used to write everything like tilted, and my cousins used to think I'm doing it like an artist. They used to come, how are you doing it? Then I came to civil engineering, and my teachers used to, yeah, what is wrong with you? Why your paper is going like this? Okay, anyways, so the point is, without a technical drawing, even a simple object cannot be made properly, like you did with this line. Okay, and whenever you make a mistake in construction or in manufacturing, it will have a lot of cost. Okay, especially in manufacturing, obviously if you make a mistake, you have seen the problems with this a model of iPhone or this model of Samsung has this problem, right? Sometimes it happens, right? And that problem is not in all the phones of that model. Same thing happens with the cars as well. This model of this car has this problem, and all the models have the same problem because they are in the same line. They are manufactured with the same procedure. Okay, so in manufacturing, then they have to discard the whole line. Okay, so if you have a drawing, you can see it, how the object will look like, and you can get the satisfaction of the client and so on and so forth, and you can make changes for future construction, future work in the drawing. So these are some points because of which you need to have the technical drawings. We start from the basics. For drawing, the basic element of a drawing, okay, from where did I start this line? From where did I start this line? What do we call the start of this line? Point, right? It's a point, okay? So the basic unit of a drawing is a point, okay? A set of points is called what? A line, okay? A set of points is called a line, okay? If you join different lines together, what do we call it? A shape. Okay, now we are reading, right? Very good. Okay, and if you are looking at a shape in 2D, okay, if you are looking at 2 dimensions of a shape, then we call it a shape. If for the same shape you include the 3rd dimension as well, we call it a form. Okay, so shape is looking at it in 2D, form is looking at it in 3D. Got it? Okay. So this is what we are coming at. Okay, so you see 2 dimensions only, length and height. Anything can be length and height. Okay, if you see the 3rd dimension, then it's a 3D drawing or a shape, or sorry, a form. Okay, 2D represents everything on a flat surface. Okay. And for our, luckily, unfortunately, for our case, we most of the times deal with 2D for our work. We still need 3D, we still use 3D. But when we go to the site, we make it into 2D, okay? Because it's easier to work with 2D, okay? And obviously then, because on the site you have labor and you have supervisors and so on and so forth, so everybody doesn't understand the 3D concepts. Okay, so now the drawings on which we work are 2D. There are other drawings which we use, which are 3D. We use 3D drawings, no problem. Okay, but for working we prefer to have 2D because site work must be made easier. Okay. What else? So if you want to show 3 dimensions, then you need 3 axes as well, right? Each dimension on axis. So in 3D or a form, you have the third axis and 3rd dimension as well. In 2D or the shape, you only have 2 dimensions and 2 axes. Okay. So there are different objects. When you show them as 2D, they have different name. When you show the same object as 3D, it has a different name. Okay. So for example, if you have this one, what do you call this one? Which shape is this? Huh? Sorry? No. Which shape? Which shape is this? You gave me the right answer. Huh?
Square.
A square, right? Okay. In 2D we call it square. In 3D we call it what? Cube. Okay. So cube is a square shown in 3D, right? Cube is a square shown in 3D. If we show a circle in 3D, what do we call it? A circle in 3D. Circle is 2D, right? Huh? 4? No. A circle in 3D. There is no circle. I don't have it here. You have seen you were saying ball, right? If I draw a ball is 3D or 2D? Ball is 2D or 3D? A football. You play football or not? Everybody plays football, right? So, football is 2D or 3D? 3D, right? Okay. And it's circle or not? The shape is circle or not? It is. Okay. So what do we call it? If you draw a football here, what do we call it? Ball? No, shape. The name of the form. What do we call it? Circle is 2D. There is no 3D. No? Yeah. We call it a sphere. Sphere. Okay? Sphere. What is the shape of the earth? Shape of our earth. Earth is which shape? Square, circle? Huh? Earth is a sphere? So that means earth has shape of a circle, right? Earth is a circle? No? No? So what is it? Square? Triangle? You don't know, but you know it's not circle.
I know, I did not know what goes on.
Okay, now get real. The Vedal is not circle, right? Vedal is not circle. Yes, this is not circle. This is what? So we agree it's not circle, right? This one is called ellipse. Ellipse. Okay. So Vedal is ellipse. Okay. Circle is something else. I don't know what it's called, but okay. I know that comes from egg, right?
Yes.
Okay. That comes from egg, the egg shape. Okay. So the egg shape in 2D is ellipse. In 3D is called ellipsoid. Okay, the egg shape in 3D is called ellipsoid. Anyways, coming back to the point that the same form, the same shape, when you show it in 3D, okay, it has a different name because of the third axis and the third dimension. Okay, so a drawing can be 2D or 3D. Okay, you can see some examples over here. Okay. So this one is 2D, this one is 3D, right? Okay. This one is 2D or 3D? 2D. Okay. This one? 2D. This one? 3D. Okay. Because you can see the third dimension. Right? Okay. The 2D drawings can be divided into 3 types. Okay. And we are talking about types of 2D drawing. Later on, I will discuss the different styles of making 2D drawings. So there are styles and there are types. This one is what? Types. Okay, this is types of 2D drawing. Got it? Later on, we will discuss styles of 2D drawing. Okay? Don't confuse them. These are different types. Okay? I already discussed the first one, plan view. If you remember last time, we talked about plan view. Okay? We talked about plans. Okay, so a plan view is made when you are looking at the object from the top. Okay, we look at the object from the top, it's a plan view. Clear? Clear? Okay. Then we have elevation. Okay, elevation. If you want to, elevation means height. Right? Elevation means height. Elevation means height. So if you want to look at the height of something, you have to look at it from the side or the front, right? Okay, meaning the front is also a side, right? This is a side, this is a side. Okay, so elevation is from the front. Okay, clear? Elevation is from the front. Okay, if you look at the elevation, can you see what is inside? Okay, so if you want to see the inside, then we draw another one which is called as a section. Okay, clear? So there are 3 types of 2D drawings. One is when you are looking at something from the top. We call it what? The plan. Another one is something which you are looking from the front. We call it what? Elevation. The other one is when you are still looking from the side, but now you are looking inside. Okay, and we call it what? Section. Okay. So the plan will show you the shape of the things when you look from the top, and the elevation will show the shape and the sizes when you're looking something from the front. Okay, but the section will provide you again form and say size and everything, but from the inside as well. Okay, so section has more details about the inside. Clear? Okay, and why it is important later on you will see. Okay, so this is a cube, as we said. It's a cube, right?
Yes.
So cube, elevation, top plan. Okay, and if you cut it, so section cube, if you cut the cube, it will same. Okay, but if your shape is this one, if you cut from, so if I look from here, what will I see? If I look from here for this object, what will I see? A box, right? Okay, only a box. Okay, I just see this one. In order to see the real shape, I have to cut the section. Got it? Okay, clear? Okay, so now you see this is a chair, right? Okay, now all of are these 2D views or 3D views?
3D.
They are 3D? How they are 3D? How they are 3D? Is this a 2D drawing or a 3D drawing?
It's a 3D.
It's 3D?
Yes.
Where do you see the third dimension? It's 2D. It's 2D, right? Where's the third dimension? Do you see the third dimension? Look here. Do you see this dimension? No. So all of them are what? 2D. All of them are 2D. Okay. Clear? Clear or not? Okay. So now you see this view. I'm looking at from where? From the top. So plan. Okay. And all of them are what? All of the others are what? Elevations. Elevation from different sides.
Yes.
From different sides. Okay. Which one is missing? There are three types, right? Plan, elevation, and section. Okay. So there is no section here. Okay. Same thing for a house. Okay. So if you look at from the top, you see only these boxes. Okay. If you look at from the front side, okay, or the front side, okay, you will see this one, okay, or this one, different sides, right? So this is elevation from here, this is elevation from the other side. Okay, so these are elevations. Okay, this is another type of elevation. Okay, the section again is not here. I believe it's same thing, colors. Okay. This is a very complicated drawing. Inshallah, at the end of the course, you will be able to make it, okay, yourselves or something similar to it, okay. But these are different rooms, okay, and these are the walls, okay. So I'm looking at the rooms and I'm looking at the walls, okay. So which view is this? Plan. Yes. Okay. Which view is this? Section? Elevation? Elevation or section? Section? Why? You see inside. You see inside, right? The people are, there are some people inside and so on and so forth. Okay, so that's why it's a section. Okay, so a line is 1D, you only need one dimension, right? Okay, so if you want to remember about or you want to analyze what is 1D and 2D and 3D, You have to see how many dimensions you can see. How many dimensions you can see. So if you just see one dimension, the length, okay, that is 1D. But if you can see the length and the height as well, that is 2D. And if you can see the third dimension as well, that is 3D. Okay. So drawing systems means different drawing styles, like I mentioned before. Okay. Drawing systems meaning how we make the drawing. Okay. How we make the drawing. Okay. So we have 2D drawings and we have 3D drawings, right? So there are different styles for each one of them. There are different styles for each one of them. Okay. 2D is drawn using orthogonal views. Okay. The style for making 2D drawings is called an orthogonal system. Okay. In orthogonal system, there are two ways to make the 2D drawings. Okay. They are not ways, they are just arrangements, two different arrangements. So 2D drawings can be arranged as third angle or first angle. Okay, I will show you these things. Okay, but these are two different methods to show 2D drawings, and both of them come under which system? Orthogonal system. So orthogonal means 2D. Orthogonal means what? 2D. Okay, so plan, elevation, section, all of them come under orthogonal. Okay, and plan, elevation, section can be arranged by third angle method or first angle method. Okay, and which one we prefer? Which one is more is better for us? Third angle. Okay, why? I will come back to it. When I will show it, it will become very clear. Why do we prefer it? What do we prefer? Okay, then all of them are for 3D drawings. For 2D, only this one. The others are for 3D drawings. Okay? Clear? Okay. In for 3D drawings, we have one system which is called as axonometric, another one oblique, and the third one is perspective. Okay? So for 2D, only orthogonal. For 3D, we have three options. And in each option, we have three different arrangements, different styles. Okay? To make it more clear, yeah, this one is better. So I told you we have orthographic for the 2D, right? You have orthographic or orthogonal for the 2D. Orthographic, orthogonal means the same thing. Okay. This one is for 2D, right? Okay. So in orthographic and orthogonal, we have two different methods. First angle method, third angle method. Okay. Now in all these drawings, we are making a cube. Which cube? This cube. In all these drawings, you see the cube. Okay. Now that this color means what? Which view? Plan. Okay. Then this one is my side view. This one is my front view. Okay. Usually, the right hand side is considered as the side view, and the left hand side is considered as the front view. Got it? Okay. Clear now? Okay. So we have the plan, the side, and the front. Okay. So in both of them, you can see the three views, right?
Yes.
The plan, the side view, and the front view. Okay. So this is by first angle method. This is by third angle method. Okay. Do you see any difference in the shapes? No, no difference, right? Where is the difference? Only in the color are according here. Okay, color is showing that this one is a plan view. Okay, this one is a plan view, this one is a side view, this one is a front view. Okay, the colors are just showing from where I am taking. Okay, but what is the difference between them? There's a plan view here, there's a plan view here, there's a side view here, side view here, front view here, front view here. The views are same, dimensions are same, shapes are same. So what is the difference between them? The first angle and third angle method. What is the difference between them? All these three are according to third angle. All these three are according to first angle. What is the difference between them? Yes. They switched the shape, right?
Yes.
Okay, they switched it. Okay. So the plan by first angle method, where is the plan? bottom, right? Plan is bottom. Okay. This one is supposed to be this side, right? And this one is supposed to be left side. Okay. When you come here now, where is the plan? They switched. They switched the sides. Okay. In the first angle, plan became bottom, right became left, left became right. In the third angle, plan is the top, right is right, left is left. Okay. Which one is easier to remember? First angle or the third angle? First angle is easier to remember. Which one is less confusing? Okay. Which one is less confusing? First angle or the third angle? Same? Which one makes more sense? Okay. Third angle makes more sense, right? Plan should be on the top. Plan means what? We are looking from where? From the top, right? So plan should be on the top. And the right hand side should be on the right hand side. The left hand side should be on the left hand side. Right or wrong? Right. Okay. So third angle makes more sense. If you are looking from the top, you make it on the top. If you are looking from the right hand side, I make it on the right hand side. If you are looking from the left hand side, I make it on the left hand side. Okay? So third angle makes more sense. Okay? Clear now? Okay. Now why do we have the first angle? Why did they bother making the first angle method? Why did we do this? Why did we do this? Why did we put plan on the bottom? And why did we switch this like this? This is right hand side, this is left hand side. Why did we switch? What does it show? The first angle method. It shows something which you see every day. You see it every day. Maybe in the morning. The mirror. Okay? The mirror. When you are looking at the mirror, what do you see? Your right hand side is
Eyes.
okay. So the first angle is like what you are looking at the object in the mirror. So the first angle method is like the mirror image. Okay. And the third angle method is the normal image. Got it? Okay. But both of them are important. Both of them are used. Okay. You can see the other are the different styles of 3D. So these are the only two we have for 2D, and you will see most of the times in the course we will be dealing with this. Okay. Then we have isometric. Okay. We have oblique and we have perspective. Okay. So I'll just give the introduction today about the 3D methods and we will just finish it. Okay. We will not discuss it later on because normally sketching and 3D images, they are used normally by the architects, okay, to show their design. Okay. In our case, I will show you how to do the 3D in AutoCAD as well, but normally we don't use it. Okay. So in 3D views, we have the axonometric view. Axonometric can be isometric, diametric, and trimetric. Okay. And then we have the oblique view. Oblique view can be cabinet, cavalier, military. And we have the perspective view, which has these different options. I have, yeah. Okay, so one style of 3D drawing is called axonometric. Axo means axis, metric means measurement. Okay, so axonometric means measuring the axis. Okay, it's a Greek word, or it comes from Greek language. Axonometric means measuring for axis. Okay, so in one of the axonometric view is called one of the axonometric style is called the isometric view. In isometric view, you have an arrangement like this where the axes are going inclined. Okay, so you can see the horizontal axes are going inclined. Okay, this is called as a isometric view. Okay, so you can see all of them are different types of axonometric views. In all of them, the common thing is the horizontal axes are going inclined. Okay? Clear or not? Huh? No? No. Okay. So if you look at this box, this is the vertical axis. This is a vertical axis, right? Okay. Or if you look at this thing, this is vertical axis, this is horizontal axis, and this is also this one. Horizontal, right? This is also horizontal. Only one vertical, right? How many horizontal axes? 2 horizontal axes, right? There are 2 horizontal axes and 1 vertical. All objects have 2 horizontal axes and 1 vertical. Okay? Clear or not? Up to there? Okay. Can I show 2 horizontal axes on a paper? I can, if you are writing on a paper or on an iPad or something, you can make 1 horizontal and 1 vertical. So how do I show 3D on a paper? Or how do I show 3D on a surface? Even on your screen, how do I show 3D? Okay, so what do they do? The horizontal axes are made like this. So you can see one horizontal axis and you can see the other horizontal axis. So we tilt them. So you can see both. Okay, the problem is where? With the horizontal axis, because I need 2 horizontal axes. Okay, so if I keep it straight, I cannot see 2. I have to tilt them. Okay, clear? Then as axonometric views, we tilt the horizontal axis, both of them. Okay, so this is one side, this is the other side. Now what is the difference between all 6 of them? Can you see the difference between them? The angle of tilt. You can see here the tilt angle is 30. Here the tilt angle is 15. Here the tilt angle is 45. Okay. Then 30, 45 here as well, but there is some other difference here. So in axonometric view, you tilt the horizontal axis so you can show it on a surface. Okay. And the different styles are in the angle of your tilting, in the angle of your inclination. Got it? Okay. Clear or not? Okay. The first 3 and the last 3, they are different types. What is the difference between them? Can you see? The first 3 are of one type, the last 3 are of one type. So now, okay. You see how much is the angle here? 30. How much is the angle here? 30. The angle is not different, right? Angle is same. What is the difference in them? Both of them are 3D. You see 3 axes, right? You see 3 axes in both of them. But what is the difference? They are the same object. Both of them are showing the same object. What is the difference between them? Tell me.
The views are.
Huh?
The views are.
The third side, you see, if they are the same, if they are for the same object, if they are for the same thing, okay, do you see the difference in their dimensions? There is a difference in their dimension, right? The first one is a perfect, what do you call, cube. Okay, the second one is not a cube. The third dimension is longer, right?
Yes.
Okay, clear? Okay, so this is what we call, so this is the difference between the both of them. Okay, so there is a drawing style in which the third dimension is made according to the exact value. Okay, and the style which you see at the bottom, the angle is same. The horizontal axis is tilting at the same angle, but the third dimension, the one which is going the other way, okay, we make the third dimension not according to the exact dimension. Okay, we don't make the third dimension according to the exact actual dimension. Okay, so this is the difference between the first 3 and the last 3. The first 3, all the dimensions are exact. The first 3, all the dimensions are exact. The last 3, the The third dimension is according to a scale. Got it? Okay, and what is the scale? Yeah. Okay, so the scale can be, so now you see this one, all dimensions are exact. Okay, you see this one, or let me go back, it will further confuse you. Okay, so we were discussing axonometric. Okay, in axonometric, the horizontal axes are tilted. Okay, they can be tilted at different angles. Okay, and the third dimension can be exact, or it can be according to a scale. Okay, so we discussed this one, which is for 2D, first angle method, third angle method. Then we discussed axonometric, where horizontal dimensions are tilted. Okay, and the difference between them is the angle of their tilt or the scale of the third dimension. Okay, then we have oblique. Oblique is also 3D. Oblique is also 3D. The difference between, this is oblique, 3D, right? This is 3D. This is axonometric, 3D. Can you tell me the difference between this one and this one? The difference between this and this. What's the difference? Or I can go here. Okay. This is 3D, this is 3D. Okay, this is according to axonometric, this is according to oblique. What is the difference? Just focus on these two. Just focus on these two. What is the difference between this and this?
Here we use two angles, but here we use only one angle.
Yes. Here both horizontal axes are tilted. Here one of them is straight, the other one is tilted. Got it? Clear? Okay. Axonometric, oblique, both are 3D. Both are 3D. In axonometric, both horizontal axes are tilted. In oblique, only one is straight, the other one is tilted. Got it? Clear? Okay. So this is the difference between oblique and the other one. Okay. So only one axis is tilted, the other one. Okay. So in other words, if you look at axonometric view, you see all faces are tilted. There is no side which is exactly facing you. If you look at oblique, you have a side which is directly facing you. Got it? Okay, so this is the difference between oblique and axonometric. In oblique, one side is facing you direct. Only one side is tilted. Got it? Okay. So, yeah. Then we have three different types of oblique view. The first one, all dimensions are exact. This one, third dimension is reduced. This one, the third dimension again reduced, but in this one, the third dimension is reduced by half. In this one, third dimension is reduced by any number. Okay. So, for example, I have this one has a dimension of, let's say, 2 by 2 by 1. Let's say. Okay. I have a cube which has a dimension of 2 by 2 by 2. 2 by 2 by 1. Okay. So if I make a cube 2 by 2 by 1, this will be the Cavalier method. Okay. Where all three dimensions are exact. Got it? If I make the third dimension half, so instead of making it 2 by 2 by 1, I make it 2 by 2 by half. Okay, and this will be the cabinet method. Okay, clear? And if I make the third dimension as 2 by 2, and the third one is not 1 and not 0.5, any other number. Okay, so for example, if it is 0.8, then it is general. Got it? Clear? Okay. So, for example, if I have a shape 4 by 3 by 7. Okay. If I make the shape according to these same dimensions, which one is it? If I use the same dimensions as it is, which method is it? Huh?
First one.
The first one, right? Which is the Cavalier method. Okay. If I make it 4 by 3 by 2, which method is it? The middle one? Sure. General. Because 2 is not half of 3 of 7, right? For the middle one, what would be the dimensions? Tell me. For the middle one, for the cabinet method. Yes. 4, 3, 3 point. Got it? Clear now? Okay. But all of them are 3D, and all of them have one side facing you. Which side is facing you? The exact one. You can see in all 3 types, I am not changing these dimensions. Okay, so these dimensions are constant, exact. Only I am playing with the third one. Third one can be exact, third one can be half, or third one can be something else. Okay. Okay, and this angle theta, it can be 30 degree, 45 degree, or 60 degree. Okay, you can change it, but it should be constant. Okay, it's not like you are making 4 drawings, one is 30 degree, other one 60, or the other one is 45. Okay, whatever angle you are choosing, it must be same for all your drawings. Okay, in the oblique projection. Okay. Okay, so orthographic or orthogonal, I told you, is for 2D. Okay, so we are looking at the drawing on a flat surface, on a paper or a computer surface, and it's a flat view. Only 2 dimensions are showing, only 2 axes are showing, and you have seen Google Maps, right? You use Google Maps. Okay, Google Maps is 2D or 3D? 2D. Okay, all maps are by default 2D. Okay, you have not taken 131. No. Okay, there you will see more maps, and all of them again are 2D maps. Okay. Now we discussed in orthogonal view, we discussed 2 methods, right? First angle, third angle, right? Okay. You see them, right? On the left hand side, you see the two methods. In each method, how many drawings? In each method, how many drawings did we make? You look at first angle. How many shapes you see? 1, 2, 3, 4. How many? 3, right? Third angle again, 3. Okay. This is the problem with 2D views. 2D is easy, easier to make, easier to see, easier to read. But is it complete? 2D is not complete, right?
Yes.
Okay. If you say there is a wall, look at this wall. Okay, this is a wall. Okay. But just looking at the wall, if I measure this dimension, is the wall complete? No. Because the wall has third dimension as well, right? So 2D views are easier, very helpful. Okay. And you can work on them, but they do not provide complete information. So one 2D view is never enough. You can have one 3D view which shows you everything, but one 2D view is never enough. Okay. So even if you look at this one. Okay. So if you are looking at only this, so you know only 2 dimensions, right?
Yes.
You don't know the third one. Okay, for the third one you need the other views, right? So 2D views are never made alone. 2D views are never made alone. I will see if I have it here. I was showing you an example. You cannot see it here, but let me see. Come on. Okay, now you see here this one. This one is 2D, it's a section. Okay, but there's a part in the section which needs more details. So I make a small drawing for this, only for that small part. Okay, so this is how we do on the construction, in the construction drawings. Okay, that with the 2D view we have to put some supporting drawing as well. With one view you have to put a supporting view as well. Okay, so 2D views are never complete on their own. Okay, you cannot say I gave you the 2D drawing and this is enough, you can do the whole construction. Okay, that's why if you go to any construction site, okay, and you ask them for the drawings, they will give you a full file like this, like a book. Okay, because they need so many drawings. One drawing is not enough for them. Okay, and one of the reason is because we are using 2D. Okay, so in 2D drawings, okay, we already started. I'll go back to the discussion of the lines. Okay, so you have this object. Okay, if you look at this object from the top, you will see this box and you will see this C shape, right? Okay, so the top view. Okay, the box and then the C shape. Okay, if you are looking at they are given the back side as well, but look at the front side. This is the front side. Okay, so the front side, what do you see? The L shape, and you see the box. Got it? Okay, the L shape and then the box. Clear? Clear or not? Huh? Okay, if you see from the right hand side, what do you see? This box and then the box on the top. You don't see this line, right? We will not see this. If you are looking from here, you will not see this. Okay, so you will see this box and this box. Okay, but if I am looking from here, if I am looking from this side, this shape is cut from here, right? This box is not full. Okay, so there is something which is hidden behind this side. I cannot see it. Okay, if I am just looking from this side, I cannot see it. Okay, but I want to show it to my client or to my contractor that there is some line behind which you cannot see. Okay, so what do? I'll make it with a dotted or dashed line. Okay, so a dashed line represents something which is behind, hidden. It is there, but you cannot see it from here. Got my point? Okay, so right hand side, this box, and I have to show this line as well, right? This box, okay, and then this line dashed. Okay, got it? No? I know, I have the same problem. Okay, see this one, I'm talking about this one. See, this is the line, right? This is the shape. If you look from here, what do you see? A box. But I know there's a line behind. It's cut, right?
Yes.
Okay. So if I'm showing this view, but I still want to show you that behind this face there is a line.
Okay.
Okay, so I'll make it with a dotted line. Okay, so how do I make it? Okay, so I'll make this box. This is my box. Okay. Now let's say after 3 centimeter there is a cut. You can see the cut, right? Okay. So after from the top 3 centimeter down there is a cut. Okay. So but you don't see the cut from here. It's hidden behind. But is it in the same line? Is it on the same direction? It is, right? So I still want to show it. So I will show it this like this. Got my point? So a dash line shows something which is in the same direction but behind. Got my point? Clear? Clear? Everybody? Any question? Any problem? Okay. So, and then they have the back side as well. The back side is a very, you can see the front side and back side are the same. Okay. If you look at it from the back side, again you will see the L shape and then you will see the box. Okay. So you can, I don't know, normally we just 3. Okay. They made the back side as well. Okay. Forget about the back side. Forget about the back side. Imagine there are only 3. 1, 2, 3. This one is not there. Okay. Now for orthographic drawing, we have 2 methods: first angle and third angle. For orthographic, we have 2 methods, right? First angle method, third angle method. I showed you. Okay. Which method is this? Top view, plan view on the top. This one front view, right hand side. This one left hand side. Which method is this? Is this the third angle method or the first angle method? Third angle method. Why is it the third angle method? Because it makes sense. Okay. Top is on the top, right? Okay. Front, right is on the right, left is on the right. So this is the third angle method. Okay. This is how I remember it. Okay. I have problem remembering it as well. So my method of remembering it, third angle makes more sense. When the top goes on the top, the right goes on the right, left goes on the right, left. Okay. Now, same thing here. Okay. Before we go into these things, let me show you something which is important. So we will do the practice. Okay. Don't worry. We'll do lots of practice. Okay. This is why I asked you to. And even if you brought iPad or something, no problem. Okay. When you are making the drawings, you should know the types of lines. Okay, when you're making the drawings, you should know the types of lines. Okay, I already told you 2 types of lines in the drawings. One was a solid line, one is a dashed line. Okay, what is the difference between them? Solid line and dashed line. Why do I have dashed line here?
Dash line, it's something behind.
Behind. Okay, so we call it a hidden line. Hidden. Something which is behind. It's in the same direction but behind. Okay, so we do it with a hidden line. And if it's a solid line, something which is visible. It's in front of you. It's not behind and it's not hidden. Got it? Okay. So solid means you can see it. Hidden means it's behind. Okay. And hidden is shown with the dash line. Then we have the construction line. Construction line is like a grid line. You have seen graph paper, right? Graph paper. On graph paper you see grid lines, right? Horizontal and vertical lines. Okay. They go in the whole paper, right? From one end to the other end. Okay. The whole paper has these lines. They go from one edge of the paper to the other edge. Okay, the whole paper has these full lines. Okay, they are called as construction lines. Okay, there is a small difference when you will use AutoCAD. There is a small difference between them, the grid line and the construction line, and I will explain at that time. Okay, for the time being, construction line is like grid lines, grid line on a graph. Okay. Then we have the line which shows the center. I will show you. Okay, center, you know center, right? Center of a circle, center of anything, right? Center point, city center. You know all these, right? Very good. Then we have dimension and extension lines. Okay. I asked you to make this line, right? And you made it, and there was a problem with the dimension, right? The size of the line was not correct. So in order to make it, in order to give you more details, I have to show the dimension, right? Okay, so how do we show the dimension? We show it like this. There are other methods as well, but this is the easiest one. So you put these lines. Now where are these lines? At the end of my object, right? This is my object. This is my object. And I have two lines at the end. Okay? These lines are called as extension lines. These vertical lines are called as extension lines. Okay? And what is this? The line with the arrows? This is called the dimension line. Got it? Okay? Whenever you show dimension of an object, whenever you show size of an object, you have to use extension and dimension lines both. Okay? The extension line will show the boundary. The size is from here to here. Okay? And the dimension line will show the alignment. It will show the alignment. Okay? Now for example, here my line and my dimension line are both horizontal, right? I can show the dimension like this. Okay? Or I can show the dimension. Both of them are allowed, both of them are used. Okay? You will see in 131, 331, in so many courses, you will see that we have inclined line, but we show the dimension on horizontal plane. Okay? Again, this is for the sake of construction and design. This they are. To dimension line, that's why dimension line is important. Okay, now you see my extension line in both cases, same point, right? From here to here, from here to here, right? But will this one and this one give me the same number? Will it be the same number? No. This length is different, this length is different, right? That's why dimension line is important. Okay? Here, dimension line is not important, right? If I delete it, okay? You know, it's from here to here, no problem. But in this case, it's important, right? I will write a number. How do you know it is inclined or horizontal? Or more important, now it's a curve. So, same extension line. Not here, actually the direction was changing. I'm not even changing the direction now. These are my extension lines. Okay? This length and this length, are they equal?
Yes.
No.
Are they equal? No, this is curve
This one.
and this is straight. They are not equal. Okay? So I'm just explaining why dimension lines are important. Dimension lines actually show you which length you are talking about. The alignment. Okay? So extension line give you the boundary of your size. Dimension. Okay? And dimension line show you the alignment. Is it inclined? Is it horizontal? Is it vertical? Is it curved or straight or what? Got it? Okay? But they are used together. They are used together. In all the examples I am using both of them, right? dimension and extension line both are used together. Okay, then we have cutting plane, right? Cutting plane. So I told you there are three types of 2D drawings. Plan, elevation and section. Okay, section gives you what is inside, right? Section tells you what is inside. Okay, now look at this bottle. Okay, if I want to look inside, I will cut a section, right? I'll cut a section, and my wife will kill me, but just imagine. Okay, I'll cut a section. Is the section here and here same? If I cut the section here, is it the same as a section here? No, you can see the size change, right? Okay, so I have to show, whenever we draw a section, I have to show where did I cut it. I have to show where is my cutting plane. Okay, take another example of this chair. Okay, I can cut the section here. Okay, above the seat. So I will see the seat, right? Okay, if I cut the section here at the legs, will I see the seat? No. Okay, so cutting plane, I will show you how to show the cutting plane, but I am giving you the concept. Whenever you cut a section, you have to show the location of the section, at which point you cut it. Okay, so that's why cutting plane is important. Right? So cutting plane is associated with the section. Okay, why it is important? Because all sections are not the same, even if they are in the same direction and even if they are for the same object. Got it? Clear? So cutting plane shows where is your section cut at. Hatching. Hatching is filling. Hatching means filling. Okay, hatching means filling. Now you look at this. Is this same, right? Huh? Same, right? Now if you look here, from top to bottom, is it the same material? No, right? This is foam and this is hard plastic. So how do I show it? I fill it with different patterns. So this is foam, right? So I may fill it like this. I'm just giving examples, okay? I may fill it like this. Okay, this one is hard plastic. So I may fill it with solid color. Got it? So hatching means filling. Okay, and filling is done to show different materials. Okay, like what type of material is used. So every material, glass has a standard filling. Okay, this wall is concrete. Concrete has standard filling. Steel has a standard filling. Okay, so when the material changes, we go to a different type of fill. That filling is called as hatching. Okay, filling is called as hatching. Okay, then we have leader or reference, something which you must have seen in the memes, right? The pictures which you see online. So a leader is this one. This is called a leader. Okay, I believe it's here as well. See this one. Okay, this is showing what? Radius. Okay, so I don't want to show the radius with a dimension line, so I show it with a leader. Okay, so you want to write something about an object, you can make this arrow and then you write it. Okay, instead of showing it with a dimension line. Okay, and you can show other things as well with the leader. Radius is just one example, but there are many other things which you can show with a leader. Okay, so a leader is an arrow. At the end of the arrow, you write some text. Okay, and the text is giving information about that object. Where is the object? Here, at the arrow. Okay, So the arrow goes from the object to the text, and there is at the end of leader there is some text which is providing information about the object. Okay. Okay, so you can see now here horizontal, vertical, you know that oblique is anything which is inclined is called oblique. Okay, ellipse we already mentioned, right? Ellipse is which shape? Ellipse is not circle. Yeah, okay, the Bedawi shape, and the circle is which one now? What do you call a circle in Arabic? Yeah, daira. Okay, same as Urdu. Okay, and the curve is a curve. Okay, so you know these things. Okay, yeah. So the first one, solid line. Solid line means what? If you see solid line in a drawing, it means what? There are different types of lines, right? We discussed. A solid line means what? Something visible. Okay. The other one, dash line, shows what? Something hidden. Okay, but it's in the same direction, same face. Okay. Center line, you can see the center line here. I didn't show you, but this center line is showing the center of the circle. It can be center of anything. Okay. So center line, you can see the center. Okay. And you should now see the difference between this one and this one. What is the difference between center line and hidden line? Can somebody tell me? What is the difference between center line and hidden line? Yes. What's the difference between center line and hidden line? Number 2 and number 3.
Just center line short and what's in the middle.
Yeah. Okay. So the center lines are 2 and the intersection point is the middle. There are 2 center lines, right? See, 2 center lines. Middle line is 1. Middle line can be 1. Okay, because you just showing the line. But center line, we are trying to show the center. You cannot just show the center with 1 line. It has to be 2. Okay, so center lines are always 2. What about the shape? Middle line, center line, same shape? Do they have the same shape? Number 2 and number 3. What's the difference? Both of them look dash, but there's a difference. Yeah. Hidden is alternate dash and gap. Dash and gap. If you look at the center line,
From center.
okay, big line, small gap, small line, big line. Okay, so there are alternative big and small dashes. In hidden line, all dashes are same size. In center line, small dash, big dash, and so on. Okay, so there is a difference between them. Got it? There.
Yes.
Okay. Yeah. Now you see the fourth one: extension line and dimension line. Which one is extension? Which one is dimension? Dimension is the other one. Okay. Then you have the leader. I told you. Okay. The last one. You see the arrow. And you can see different types as well. Okay, so for the dimension line, instead of arrow, you can use dash as well, no problem. Okay, arrow is not important. You can even use it without the arrow, without the dash. Okay, the dimension line, extension line. Leader again, different styles. Okay, leader with 1 arrow, leader with 2 arrow, leader without any arrow but a point, and so on. Different styles. And what else? Yeah, break line. Break line, I did not mention it in the previous slide. A break line shows that an object is only shown partially in a drawing. The object which you are looking at is not the full. It's not a full object. Okay. Now I'm only showing you part of the object. Okay. For example, you look at this column. Okay. Now if I'm looking from the side, I'll see this column, right? Okay. Is this the end of this column? What you see here, is this the end of the column? does the column end here? You know the function of the column. Why do we have a column? Why do we have a column? This column is doing what? If I remove the column, what will happen? It's a support, right? Okay. So is this support only for this floor? No, it continues, right? So if I make elevation here for this room, I only see column up to this roof, right? But is this the end of the column? No, the column is going to the top, right? Okay. So how would I show the column? So this is my room, and this is my roof. Okay, but the column goes to the top as well, right? But my plan is only up to here. My drawing is only up to here. So what will I show here? I will show a line like this. This is called a break line. Okay, so whenever I see the break line, I know this object is continuing. I don't see it in the drawing, but it is continuing. Got it? Clear? Sure. Busy with the friends. Busy with the friends. Yes. So a break line, when you see a break line, okay, so you see a break line here, right? Break line means, yeah, my drawing is up to here, but this object is not ending here. Got it? Clear? Okay. What else? Yeah, okay. Then you see the phantom line and the cutting plane line. Okay. Phantom line. Okay. Before phantom line, let me explain cutting plane line. I already mentioned cutting plane line is used for showing the location of the section, because all sections are not at the same, will not look the same. Okay. And give the example of the bottle, right? Section here is different. Section here is different. So if I make the cutting plane here, I will see this mouth. If I make the cutting plane here, I will see this whole bottle, right? Okay. So the cutting plane line, you can see, is shown like this. You can see number 8. This is my cutting plane line. Okay. So this is the location where I am cutting, and from where I am looking at, the arrow shows the side. The line shows the location. Okay? Clear? Okay. So if I make this bottle, okay, if I make the cutting line here, then I am looking from this side at which location? This location. Okay. If I make the cutting line here, I am looking from this side, which location? This location. Okay. And what changed? I am looking from here. Location is same, but I am looking from here. Okay. In many cases, this will affect. In this case, maybe not so much. Okay, because it's a very straight object. But in many cases, it will have an effect. Okay. For example, this room. If I look from here, what do I see? Windows. Okay. If I remain on the same location, but I change, now what do I see? The wall. Okay. So that's why direction is important and the location is also important. Okay. Then we go to the again section line. Same thing as cutting plane. They use it in mechanical. Okay. So we are not cutting the whole object. We are cutting part of the object. The difference between cutting plane and section line: cutting plane is for the whole object, and section line is for part of the object. Okay. So I'm not cutting the whole bottle. I'm just cutting half of the bottle. Okay. So that will be section line. Coming back to phantom line. So for example, I have an object which is moving. Okay, something is hanging. Okay, so it's moving. Okay, it's not stationary. Okay, so I want to show the dimension of the object, and I want to show its movement as well. How much it moves. So then I will show it with a phantom line. Okay, phantom line is a copy of the actual object. It's a copy of the actual object, okay, but at a different location. Okay, so you see my object is what? This is my object, right?
Yes.
And this is the phantom line of the same object. Okay, no change in size, no change in shape. Okay, only the location change from here to here. Now what does it mean? The object can move from this location to this location. Got it? Okay, so phantom line shows the movement of the object. Okay. In civil engineering, when we design a building, okay, now alhamdulillah in Bahrain we don't have the problem of earthquakes or very high wind speed, but there are other parts of the world which have this problem. Okay, so or even in Bahrain, if you are building a very high bridge or very high building, where you go like Bridge Khalifa, something like this. Okay, so it's very tall, right? Very high. In these buildings, there's a problem of wind load and the building moves because of the wind load. Okay, if you ever walked on a bridge, okay, when there's a heavy traffic on the bridge moves. You can feel it. Okay, so in civil engineering, then we show how much it is moving because of the traffic or because of the wind. Okay, we don't in buildings we don't feel it, but there's a movement. Okay, whenever there is earthquake or whenever there is wind load or whenever there is heavy traffic, there is some movement. Sometimes we feel it, sometimes we don't feel it because it's very low. Okay, it's very, very low. If it's very high, then it will fall, right? It will fall. But we show it with phantom line. How much the building is moving, we show it with phantom line. Okay, we still have to show that yes, there is a movement and this much is the movement, 0.1 millimeter, 0.2 millimeters. Okay, so this is where we use the phantom line. Okay, got it? Clear? So the building will have the main, and will after 0.1 millimeter you will again show the building can move this much because of the wind or because of the earthquake. Okay, same thing. Yeah, another name for phantom line is a ghost line. Okay, ghost line, phantom line means the same thing. Okay, what else? Hatching, I already told you. What was hatching? Hatching means what? What is this? Yeah, hatching shows the materials with the filling. Okay, and then we have the leader, the brake. I already told you about these things. Okay, let us have a break. Okay, 5 minutes. You can move around, and after the break, we will practice some of the 2D shapes. Okay, how to draw 2D from 3D. Okay, we'll do some practice. Sure. I will show you some examples, and you will do some practice. Okay. Ready? Okay, so whatever you have, iPad or tablet or paper, okay, you can try. Okay, so what we are going to do here is we will manually sketch, okay, some of these 3D shapes, and we will try to make the 2D forms from the 3D shapes, okay, and you will see how we can apply the concepts which I just told you about, okay. So for example, you see this 3D image over here, okay. If I look at from this side, I will see the shape like this, okay. If I look from the front side, I'll see this box and this box, right? Okay, so you'll see these two boxes here, okay. If I look from the top, okay, I'll see this big rectangle, and what else? If I'm looking from the top, I'll see the big rectangle, and what else? The dashed line, okay, the hidden line. Clear? Okay. This one, okay, if I'm looking from the side, okay, I'll see this L shape, right? This L shape. And now we have again hidden line for this thing, right? I have to show a hidden line for this thing, okay? And then there's a circle as well, okay? Now the important thing to keep in mind for a circle, okay, if you are looking at the circle from the side, if I'm looking at the circle from the side, okay, not the front, the side. From the side, you just see the outer lines of the circle, right? Okay, you will not see the whole circle. You will not see the radius of the circle. You will not see the diameter of the circle. You will just see lines. Got the point? Clear or not? Okay, so if I'm looking from here, okay, I'm looking at the side of the circle, right? So I will not see the circle, I will just see two lines. Okay, clear? Okay, so I will just make two hidden lines which are just showing me the two edges of the circle. Okay, and then there is another line here, this one. Now this one is showing what? It's between the two lines of the circle. This is showing what? No. The center line. Okay? Clear? So two hidden lines for the edge of the circle. And one line in the middle showing the center line. Okay? And you can see the center line is extended. Center line is extended. Okay? If you're looking from the side, same thing. You will see this box. Inside the box, two hidden lines for the circle. Okay? And then one center line. Okay? Then above this box, we have this shape. Okay? The C shape. Clear? So you see this one here. Okay? If somebody wants to see the complete circle, he can only look at it from where? From the top. Okay? So if you are looking from the top, you will see this box, this box, this box, this whole box, and inside the box the circle. Correct? Okay? Which you can see over here. I'll show you another example. This one. Okay? So, if I'm looking from the front, I see this box. Okay? I see this one. Okay? Now what are these two? The circle. Okay? And what I should have? There's one thing missing. The center line. Okay? The center line is missing. If I look from the side, I see the L shape. Okay? The L shape, and I will see the circle. Okay? Clear? Okay? You see the L shape, and then you see the circle. Okay? And then, yeah. There's another line here. Okay? This line is for this one. because this object is only at the top. It's not solid. It's not coming to the bottom. Okay. So you see another hidden line here. This hidden line is for the back of this object. Got it or not? Okay, the back of the object. Okay. And when you look at from the top, you see this box, square. You see the whole thing, and you see the circle. Got it? Clear? Any questions? Okay. Before you start drawing it yourself, I want to show you something. Okay, so this is now with the inclined view. Okay, again, which method is this? First angle, third angle? Which method is this? First angle method, third angle method? Yes, yes. First angle? What did I say was the difference? Third angle, okay? Because the top view is on the top. Okay? The top view is on the top. Okay? So, you can see the inclined as well. Okay? When you're looking from the side, you see the inclined. Okay? And this one. And then when you look at from the side, okay? So you see this L shape, and above this L shape, you have another L shape as well. So, two L shapes. Okay? What I'm looking for, they did not show it here, but somewhere. Anyways, they have shown how to in the slides. Okay, you will see these lines. Where is it? These lines. Okay, right now we are just doing the sketching. How to use, what are these lines, how to use them, I will tell you in AutoCAD directly. Okay, clear? Okay, because right now we are not using any dimensions. We are doing it on paper without dimensions. Okay, so that's why. In AutoCAD, we will try to do it accurately. Okay, now make the 2D views of these drawings. Use the first angle method. Go ahead. If you have the scale, use the scale. If you don't have the scale, just sketch it. No problem. I want to see the shapes. I want to see the shapes. So this session is only about you doing practice. Sorry? No. Just make the shapes. Just make the shapes. Okay. So you can use the third angle method, the first angle method. Okay. So in the third angle method, top, left hand side, right hand side. There is a third angle method. Okay, so make the top view, under the top view, make the right hand side, no, the left hand side, on the other side, make the right. And the purpose of doing this is that you ask me if you have any problems. The purpose of doing practice is so that you know the concepts, you clear them, and you ask me for any problem. Okay? So if you have a problem, still draw it so I can know it. And I can explain it to you. And you can ask me. Okay? Before drawing it, you can ask me, no problem. Just a hint, there are no hidden lines in this one. So it's very easy. There are no hidden lines here.